All right. Hello, everyone. I'm Junchan, and yeah, we're back on stream, and I'm back showing my face. Whatever, doesn't matter. And what are we doing today? We are coding, and so if we are coding, then I'm going to need my Visual Studio Code Editor. And here we have our log. So let's do what we do. We create one for today. We've been doing religiously for quite a while now. Let's look at for how long I've been doing this. So I started. Wow, that's earlier than I thought. What? Hold on. Oh, what? Yeah, okay. Yes, so the actual streaming. So I started streaming December 20th last year. So we're at our like 4 months and 9 days. All right. But I've been doing logs personally for a while, actually, really. What's in there? Oh, some stuff. Interesting. What's in there? Oh, some more stuff. Okay, that was a little look at the past, at the beginning of the long stream of log folders with a date. But today we are April 29th. And what are we up to? Well, one of the things that we're up to is launching the chat client, right? So that I can hear it when there's a chat message coming in. So that is where that might be in documents, and right, I think I need to go into documents, and it's just not in documents. So Java and minus jar, I think, and chatty. Okay, and here's chatty. And so in theory, we'll check, but we have a bell that should ring for all messages, and we do. Okay, awesome. So let's put this on the side, and what do we have? Let's check out our mosaic. How about that? Yeah, that's what we have. We have my second screen here and my camera, and then there's a bunch of stuff that we're just not receiving video from my living room, right? Okay, so that's what we have. And then what else? Well, then we also copy the streaming log, because that's what we've been doing, and I'm extending this. We are now April 29th and we're still doing streaming tools. Why is that? Well, because I really like it. Super excited to make progress on this. Plus it's this really cool mix of, more like very engineering things by, connecting to GStreamer and like running pipelines through Haskell, but also this very theoretical stuff around free arrows and graphs, and that's really a good mix for me. I really like this kind of thing. So therefore we continue. We follow the love. We follow the direction where our intuition tells us there is joy to be had, and also purposeful joy in this case. All right, enough waxing lyrical. We were playing with free arrows, and we kind of built a graph. So what does this graph looks like, you would ask, and you would be right. And it looks like what we have in design here. It looks like this right now. It's a linear pipeline, but it's basically doing the same thing that our imperative version did, it's creating, well, you know, it's none of this is actually plugged into GStreamer yet, right? But this is the GStreamer code. It creates like different elements, and then those elements are bound to a pipeline, and then elements are then linked manually pairwise with a special case where there's actually a kind of a hook of sorts, right? Like this is a dynamic linking which occurs when the code has figured out what it needed to be, because the code is actually a GStreamer element that, based on the input it receives, is able to say, well, okay, I need a MP4 container demuxing plus a H.264 video decoder. So decodebin is able to infer that automatically, but that means that it creates itself dynamically. And so in order to link it to the next step, which in this case is going to be a video converter, we need to basically say when the code has a pad added to it, then link it to conv. On element pad added, right, takes a and an element pad added callback. And so on pad added is actually a callback that's defined somewhere here, right? That says, okay, you give me the decoder and the pad, and then I just pad link. So a pad is a port inside an edge of our graph. So that's actually going to matter at some point, because one of the questions that we had hanging when I finished the stream a couple of days ago was, what should be our type of basically edges between our GST elements? And sounds like it's going to be something that has to do with pads. But if we want a hypergraph, I guess you could call it, do we need a hypergraph? I mean, in first approximation, we might not, but I think a GST element can have an infinite amount of pads. I mean, I know that it can dynamically create, allocate pads, but I think it can also have multi-pad output, like for instance, an audio output to a quadraphonic sound installation or something like that, right? Or a 5.1 sound system. Each pad would have a different audio signal and be connected to a hardware output on your audio card. So we have a hypergraph. There's really not much to say here, because if this was what I was giving as an example, like my audio interface, and this was a 5.1 converter, audio converter of sorts, then C, which connects conv to sync, will need to be basically six channels. Okay, Twitch API stuff is not exactly what we want to see here. Maybe we do want to see this. Yeah, probably. Okay, I'm going to drink a little bit of pineapple juice. Delicious. And right, so there's this makes me kind of want to look at like more theoretical stuff, but I know that if I do, I'm going to be lost in space. So what would I do just if I kind of winged it? I mean, the first question that popped to my mind is, conv has pads. So are C pads? Is C really a pad? Not really, right? But so if con has pads, then maybe we just have pads here. And so if we say that, okay, like the part of my brain that's sort of pattern matching on theory is going like, oh, this is the decorated cospans thing. And I think it is actually the decorated cospans thing. If I have a hypergraph category here with pads being actually like arrays of pads or a list of pads, then I think that that C has the type of the decorated cospan, which basically means that it's just a mapping from output pads of the conv element to the input path of the sync element. And that matters because then it allows us to maybe return sync and then have pads, output pads there, and then have the compositional structure that we want from this whole decorated cospan hypergraph thingy. So that makes some sense, but then I think we have a problem with the type of C, because now type of C is just list of pads, and so it feels like what I'm saying is that maybe we have something like that's an edge, and that's a free A component pad list of pad, which doesn't necessarily tell us much at this point, but basically, oh, actually, hold on. Maybe that's not. But the thing is that this might be a what is it called? Maybe a no-op. Well, it depends, because now sources have paths here. I think they do. Okay. Okay, so we need to re-indent in our weird Haskell ways. Okay, more symmetry, more. Have it. Okay. Yes, yes, brain. I shall do it. Okay. Right, so a transformer takes a list of paths to a list of paths. Oh, interesting. This idea of the opaque interpreter. So in Piponi's post, there was something really interesting about how he dealt with the type of his state operation. And the one that's called ink was basically past identity. So it's kind of a no-op arrow in some sense, I think. Meaning it just, in the world of data flow of the arrow, it does nothing. But behind the scenes, because we are sort of implying that there's a kind of an interpreter world, then the interpreter takes it, notice, oh, it's ink. So even though in the world of arrows you're not supposed to do anything, in my world of interpreters I decide what to do. And there was a question there about, or remark, which I think is also a question, which is usually you follow your nose and you have only one representation, but here there's some flexibility in how you can interpret the store component and how much is deferred to the interpreter. And so that's specifically around this, around the type of this ink. we intend for ink to increment a register, but it doesn't know anything about registers. Nothing in the type of ink refers to that. So that's the kind of weird bit, but it implies a little bit that there's no reason per se that ink couldn't be aware of ints, and therefore maybe even like basically making a leaky abstraction from a store standpoint, but where you could maybe modify the int also in ink. So it's an API design choice here, but it's also very neatly positioned into my good old pairing abstraction of monad and comonads here, except that we have free arrows and I think co-free arrows, because co-arrows are arrows, but yeah, but there's a world of interesting theory to invent here, because when I searched for it, it wasn't there actually. So I think we might be, I mean, yeah, it's one of these things that's probably exists in math and is very non-interesting in math, but it's fun and maybe has value in computer science. So did I make a note of that at least? Because I think this is still, after a few days, a valid thought about arrows, and I might have just written this elsewhere, but not here. Okay, do I have pair here? I don't have pair. So yeah, so I must have written it in the code, but let's write it in here, because I think that's in fact a kind of a strange outgrowth of this work. But if we go with 3 arrows, then there's a co-free arrows pairing possibly with the co and with basically the comonadic tricks, comonadic UI tricks, like co and the like the product interpreter of sorts, right? And that might be research. Maybe. Yeah, crazy. Okay. Oh, hold on, I see something interesting there. UI, event source, UI vertex. Right. No, that's yeah, that's not of interest right now. So what I said that we should do next is play with interpreters. So and define the types. So I've been actually starting to do the type thingy before. So is it list of paths? It might be list of paths. Where does the decorated cospan thing come into play? Right, so we're backtracking here to ink. So here we have the same question of design, of what we let the interpreter have as opposed to what we allow sort of the whatever the arrow describe. It doesn't have to be a data flow really, right? It's just an abstract data structure at this point, especially in this free arrow variant. So it's just something with sources and sinks and transformers and no ops. So it could be that there's a better definition of component. It could be that we don't care about sources and sinks. It could be that this is too developed. But there's also this question about then, do we carry information about edges and hyper edges? And maybe I should start with edges before going to hyper edges as well, because that's a bit. Yeah, the problem though is that if we don't go with hyper edges, then then the edges are trivial, and then it doesn't really matter. Then just the declaration of C can be unit for all we care. It doesn't need to convey content apart from the connectivity aspect, and we can still have like a DAG, and we can even have, with a row loop, we can have an arbitrary graph. But I was thinking, by the way, that this is good that we have pipelines, because pipelines are DAG, and DAGs are simpler than graphs. We don't need loops, and so that's good, because then in some of our future work we're probably going to need some loops, and so if we've played with this quite a bit, then it's going to be much easier. So there's definitely two ways to go. I could play with the interpreters first, and maybe that's really my instinct from last time was right. I think I shouldn't define the component type first. I should play with interpreters first. Why? Because that's going to give me some better intuition of how we go from a list to a tree to then maybe a graph, and then we can do that while having in fact unit as the kind of carrier type, and that's going to be the simplest thing. And if that's sufficient for a graph, I suppose it's sufficient for yeah, that's really good to do this, because it's sufficient for graph. But then all the question about whether we have labeled edges or not, that's going to come into play. And here, for instance, if we have units here, then it's a bit like, oh, then maybe the edges could be in the interpreter. That doesn't, like, I've been thinking about this for a while now that I've been talking about it, but that doesn't sound elegant at all. Why would you define your nodes like declaratively in the arrow notation, like so, and then the edges somewhere else? It doesn't make any sense. Particularly if we have labeled the edges, right? So I think there's a temptation here to go with unit, but I think we might want to go in between those two extremes of unit, where it's a not unlabeled edge, and the other extreme of like a labeled hyper edges. Let's go in between, which would be just a single labeled edge. So where would that label be carried? I suppose we could say that it's pad, and then an instance of an edge is a particular pad. If that's the case, then the particular pad of C, we do get it from the code. So then there's a question of whether sync will accept it or not. But it's definitely Conv's job to declare it. So that seems to work semantically. So cool. So let's try with pad then. And Conv will go for pad to pad. Sync will go from pad to blah, and then we don't need an edge. And to be honest, I don't even know whether that actually makes any sense. But now C is some representation of what the outgoing pad is, which, by the way, makes me think about how GStreamer does negotiation, like format negotiation. I forget how it's called, but GStreamer does this between elements. So maybe that's something we want to be able to represent, that negotiation, meaning C might be instantiated to a certain term. Ooh. Interesting. Okay. GStreamer content format negotiation between elements. might mean that conv and sync, for instance, determine the type of C it's gonna say after the fact, but the question is, where is temporality here? Clearly, we're still at the stage where we're defining a pipeline. So, and we will in Haskell, remain in the realm of declaring a pipeline, because it's GStreamer that's going to deal with the actual data flow anyway. So really, time for us can very well be about, indeed, a C starting with like an empty pad with an undefined format to then become a C with a negotiated format. So then this graph kind of copies itself as time advances, and then both edges and parameters can evolve in time, which then starts feeling like a lot like FRP, of course. But then the question becomes, yeah, how do we model? And it's connected to another thing, which is that the graph structure itself can evolve. So how do we model time, both for let's say element parameters like location, for edge terms like format negotiation. Or for the graph structure, which is the more ambitious thing, but we need to get there. We want to get there. So here maybe it's like some kind of patching, like graph patching language that we need to invent, or well, we need to just find in the wild and tame to bring it into this house. Okay. Trying to think about how that would even work. Like for the simpler case, like element parameter. If we had, do we want to do something like where we get like, we get T from like a reader of sorts, and then we say that this is location of T, and then we have location which takes like time and returns a string. Then we say we ignore time for now, for instance, and we return this. And for now we say something like time is just an int. And we define a time arrow that would be like a free A component unit int, or a time. And then what would time do? Time would time could be a no op. Okay, well, we're not gonna want bad arrays. I'm gonna suffer with this indentation. Or is it a transformer? Well, in our case, we don't care about paths. So actually this type is problematic from the get-go. So that totally feels like the moment where we introduce like something like a transformer stack, like the Dunai way, right? The A to B of M MSF MAB. Oh no, it's not like that though. It's BM and a B and an MSFME, like this. I think I have this just right. No, I don't. Oh yeah, I do. Right there. MSFMAB, A to M of B, MSFMAB. Right, so that's then we go and grab the other. So in 2 talks ago, I talked about this. Well, actually, yeah, I talked on stream about a video that I wanted to watch, and I did watch it. And it turned out that this thing that we picked up from Stack Overflow that we ended up not using so far, and I really say so far because that might be the moment where we actually switch to this representation, because this representation is part of this talk that was given about extensible free arrows, and it's right here. Here we go. And the uses in this law firm, which was really interesting. Unfortunately, it means it's not open source. I say this, but I don't even really know. So let's actually copy that type and see whether we can find it in GitHub. That'd be interesting. Well, except GitHub is. Oh, there we go. There we go. Lambda conf nodes and SciFlow. Draw arrow free. Ooh, an even more advanced representation right there. With FAL being a type parameter. So indeed, this made me think a lot about Dunai, which was my intuition when I looked at it here, and now we're back into it, and we'd want a stack. Why? Because it would allow us to transform the kind of this arrow that represents, you know, the data structure that we can care about for now in terms of setting up the pipeline, and then in another stack orthogonal to that, take care about something like time and say, well, actually, I want to have an underlying ticker underneath or around this definition of the pipeline. And that's exactly the move that Dunai makes. And then I think that if we follow that route, then maybe we open up the possibility to actually also do like Rhine style clocked typed clocks. I don't know if we're going to need typed clocks here because really it's going to be GStreamer that's going to be doing all of the synchronization. But on the other hand, nothing really prevents us to use the type system to, in fact, configure the synchronization of the underlying GStreamer elements, which would be kind of an interesting hybrid approach. We probably could learn quite a lot. I mean, it's quite a move to actually go from even this representation where there's an M or an F in order to sort of stack effects, which, by the way, this does it even stack effects? Yeah, it's not even clear that it does. This just lifts an effect, but it's not exactly like that. So we need to first understand how this works and play with it a bit. It feels to me that maybe there is another point in the design space, and I don't know whether we want to be closer to the Dunai interpretation or whether this would work. I think I need to go back a little bit into some parts of the talk. Extensible free arrow. He gives an example at some point. So the instances, and yeah, that's an example. Right. So one of the things is that it has free effects, and so there are effects, and right, they don't have to be. They can be pure kind of type level descriptions of effects. So like row types, I suppose. Is that how it was? I forget what he used for. Oh yeah, there was this thing with his. Difficult to read, but we had this in the Stack Overflow post, so let's go check out the Stack Overflow post again. Yeah, the interpretation of effects is done through some F2 FR thingy. All right, no, this one is a specialization to monoids, so here it's exec, and exec has type for AB, FAB to RAB. So that's a way to transform an F into an R, and he was doing something with Kleisli IO, I think, to get there someplace. Oh yeah, and then Sjord lifted it to higher kinded well, arrows. Which I don't quite understand yet. Let's see where he used Kleisli. I think it's in one of his interpreters. Wow, it's so hard to read. Right, yeah. So see, these are like kind of like row type like. So it's a bit like MTL. So it's like type class based way to say any effect which includes printx or any effect which includes storex. So that's kind of yeah, the way that Haskell can model row types. Right, so that was the whole point of the F, is that it used an actual MTL style extensible effect approach. As a way to, I think, address the expression problem. Which is very different from the Dunai aspect, which is very plain monads and monad stack transformers. So I suppose, is there a Dunai, kind of a type classy version of Dunai? Classy Dunai? Oh, that's never gonna work. Packages. Yeah, I say it's never gonna work because Dunai is already hard to find. Parents. Okay, classy. No. Validation function core. Yeah, I think it's definitely not there. So I suppose we could actually go to this to the machines package and the good old mealy machine comment, and really we want mealy t, and so we have to go back to contents and go to mealy t and see the Colombian exchange of MSF things that have the same type, and then take a quick look there. So here is M. Okay, maybe I need to read something about how to move from a traditional monad transformer stack to like an MTL style. And then maybe I recognize how we could potentially apply this to MSF. And then maybe I recognize how, whether that gets us closer to kind of arrow-y way to think about things. I mean, the other direction would be to try, because the MSF has obviously an arrow instance. So I suppose we could, would it be equivalent to return MB here? Now I'm thinking, I think I actually know how to move it from like the traditional monad stack transformer to MTL style. I mean, I know from the user perspective, you just leave the M undefined and then you move what you want from the M into constraints. So I suppose in the reader T context, oh, that seems like a fairly different interpretation, but where am I going to put this? Let's put it at the bottom. Okay, do I like thoughts? Okay, we're saying MSF MAB is A to M of B, comma MSF MAB. And then we have things like, for instance, I think like a Yampa signal function would be of type something like MSF reader T time identity B identity AB, something like that, which expands to something like an A to a reader T time identity B B comma MSF MAB, which expands to something like it's a function from from time to be MSF MAB. Right, because this is just reader time identity, and I think let's go reader. Reader RA, no, that's run reader. Well, kind of the same thing, yeah. Yeah, so yeah, that's right. Okay, yeah, that's fine, but that's not really super interesting. What was more interesting is if we go the route of saying, well, actually my signal function has constraints such as that we have like a monad reader of time m. I think these things go monad reader, and then we have a to mb MSF MAB. So that would be the MTL way to do things, and this is really not much magic to it. So that's not really the more interesting part. I suppose the interesting part is, can we break this down into a free arrow? Is there a, well, actually I want to see if things compile here. Is there a that MSF first of all, does it need multiple constructors? You know what? I'm not even sure that it does. So we're saying maybe just A to M of B. Right, I think that was my intuition. It's just A to MB. Holy moly, I'm starting to see a pattern there. So it wouldn't be exactly MB. It would be MB and K. If we use like a pattern functor style approach here, it's like a continuation. But we don't really have that in how we define components here, right? That would need to be MAB. We don't really want to put MSF MAB in here. I mean, I think there's no problem in having a single type constructor for our free arrow. So what goes here? So if we look at again the Stack Overflow post, then we see that we have the separation of pure and effect, right? And then like sequential composition and parallel composition. It's so interesting that that Piponi lands on something that feels so very different. Oh, hold on. Yeah, I'm not looking at the right thing. Or am I? Would I need to change the definition of free arrow here? Is the question actually. Yeah. So hold on one second. Here, free A is defined with this two-type constructor and this profunctor and this sort of appendy thing. Here is defined in a completely different way. Or at least what feels like a completely different way. I was looking into that, wasn't I? Because I think it was described maybe by Swordfisher here, maybe not. Where did I? Now thinking that there was a sort of a progression that was visible. For the BXAB. Right, the CPS. Oh, hold on, where is this coming from? New type free FAB. RR F2R RAB. Okay, I think this is what's described in right here. Yeah. So it was there. This definition. So that sits kind of in between, and that might be what we want, maybe. This seems to have some kind of continuation feel. Also, if it's CPS style, it's going to be fast. And this type looks a lot like the interpreter, right? So it's kind of like you bake the interpreter in somehow with this higher kinded natural transformation here. It's like a binatural transformation, or maybe a pro-natural transformation or something. Don't know. I don't think that exists where I said. But I'm saying this because is it natural in A and B, or is it natural in B and contra-natural in A? I don't think that exists. So it might just be binatural. Do we want to play with that representation? I mean, we're clearly missing an F, and we have arrows defined in another module here, which is why I was confused. And it's hard to squint on this definition of free A and see this definition of free A, to be honest. I mean, first of all, this one is defined from a profunctor, whereas this one, not at all. So that's important actually, because with this particular design, we need to have a profunctor instance here. And that's a bit mechanical. Not very pleasant to do, to be honest. So do we free ourselves from that when we do free AB defined in such a way? It could very well be. Because we don't have the category and our instances for it. Totally worth exploring indeed. Plus there's a package for it, so let's just install the package and let's play with it into some other some other file. Free functors. Hello, hello. Free functors. And we go to our shared workshop and streamline, and we mix develop, and the Kabbalah file has changed, so we will try and do things, which is fine. Hopefully it's fine. Didn't pin state, did I? I did not. So yeah, maybe I should have. There's a log file though, so shouldn't that pin the Kabbalah state? You would think that it would, but it's possible that it doesn't. Otherwise, why would you be doing this? I mean, in this case, it's trying to also get free functor built and have dependencies available and all that. So kind of makes sense, I suppose, that it rebuilds stuff. Only reveals that. And then the local Hugel if we needed it. That's cool. Okay. Yeah, so we'll have free functor. And then what? Then do we do this in here? We probably want to do this in here. So we'll import. We'll look at some examples like automaton, and we'll import yeah, it might not be here, the arrow stuff. That might actually not be in package, curiously enough. So I'm starting to think that this design thing should just leave with free arrow, because separating them doesn't really have a benefit. But also we might send this to an experiment folder later. So this would be what? This would let's be ambitious and call it graph. And that's too ambitious because it's not, it shouldn't be a folder. All right, so graph.hs. And give me a module graph where these things are and where you're also going to import therefore. Well, curiously enough, you're just going to import this. Yeah, I think that's the only thing. So, and that's what that would be in H3. Yeah. Natural. Oh, so it wasn't by natural. Let's see whether there's in HH3 there's, yeah. How do you call those? So that's a more ambitious version of it. Do we want that? Where does it buy us? JAB to FAB. It buys us the capability to define a natural transformation that depends on the input type, not just the output type. So we kind of need that. Okay, well, let's import data.functor.hh3 and go someplace strange where we're going to need explicit false or right-hand types if you want. We're going to need control arrow, and then we're going to do more. What's your dealio? Illegal type operator? Sure, type operator. Okay, and then we want control category. Is it control? Maybe it's data. No, it's control. And then we want the prelude. Oh yeah, but we want. Is that what's going on? And do we hide the dot? I think we have to hide the dot too. Ooh, yes, we do. And then apparently we could have types. Can I do control dot? Yeah, maybe, but I need to be there at signature and at signature. And what's up with the F? What's wrong? It's just a warning, I think. Yeah, because we're stretching a bit the type. Oh no, of course we changed now. With maybe with this with h3 was fine, but now our P is a bit more muscly, and we don't what? We don't run free A, we run do we run GS3? F2G GAB for G. So it's pretty much exactly run HH3, but with the arrow constraint on the return type. But oh, but that's C. So it is HH3 arrow. HH3 arrow. F. Arrow, yeah, F. Wow, fun. Okay, so let's try this. New type, or maybe even type. Free AF AB equals HH3 arrow F AB. How about that? And then we need to pattern match on HH3, right? Yeah. But to be honest, don't we have the, oh, hold on. Don't we have the arrow and category instances already? Ah, we can't define them for categories, but hold on, we already have them. We have them, in fact, oh, that's so interesting. We have them, okay, what is this? Is it if C includes arrow? Is that oh yeah, that's well, it's that's like some of the Edwards like subdict kind of things. Is that, does that predate like constraint kinds and whatnot? Probably does. 1-to-1 2020. Could this be rewritten with constraint kinds? Don't know. Constraint kinds. That's constraint kinds. There's also HHCO3. Higher or two-type parameter for constraints. C. Yeah, I think this constraint kinds doesn't mean that. I mean, what does it mean for? Yeah, for this guy, doesn't seem to mean anything. I mean, I think this means what we want. It means we don't even need to define these. I think basically it's kind of what it means. Also means I think that we can run HH3. I'm going to put some socks on. Run HH3, but oh, probably not FA. Just run FF3, HH3. No. Yeah, but I think that's it. Like, why wouldn't we be able to use this? Is this not? It is defined and takes a P, and HH3 arrow FAB. Oh, is it because of expected type 3A? Ah, it's because of the type signature. But so is it just because it's just more generic than this? No, it's not. Okay, so let's try and reverse it and see what's up with actual type P. Right, okay, yes, it's because this was the old signature. No, it's not the old signature, it's the one picked up from the Stack Overflow. But the one picked up from the Stack Overflow is only for a natural transformation. So let's look at what H3 looks like as opposed to HH3 that we've been looking at. It takes an F2G and returns a GA. But in the Stack Overflow thing, oh well, in the Stack Overflow thing there was a type signature. That's the thing. Add constraint kinds and okay, type signature. Okay, that's nice. But then we've got some. There's a problem with the P here. Sounds like we need the P to be defined as arrow AB to, or FAB to arrow AB. FAB to arrow AB, or we could say maybe RAB with the constraint on R. We could put arrow here, and we're getting close, but not quite. On the context arrow R. Oh, that's probably because we need F or R. F. And then we need R here. And then you want CR, and instead you get arrow R. Ah, but that's because we don't have arrow here. And it doesn't work still. It's close though. A1 with A. RB 4R. Is this because are we missing false? No. What is A1? A1 expected type F A1 B1 R A1 B1 actual type F AB R AB. That sounds like maybe a type extension to be activated of some sort. What we mean here is free A blah, right? Can we just, no, we can't make a constraint general now. Do we need like scope type variables? Is that a thing? Scope type variables. It's a thing, but it's not what we need. Is it an existential? Is like the for R here? And what aggregate types? Binding for, oh, so it's right, it's like this. No, but needs to be rank n, I think. I don't know. Shadow the existing binding because there's a binding here. Yeah. So no. Not that, and then if we say for all, then it's like where are my other variables? And yeah. So what would you like this to be then? In theory. Something FA1, B1, but you're not happy with that. Yeah, I don't get it. I mean, it could be that we don't need that also. That we should just play with some of the existing stuff that's in here, because what we really want is, yeah, something like, so right adjunct. Oh, so that's h3, not h3. So it's h3. Some deriving of instance. What's Q? Tell the Haskell. I see. Right adjunct. Okay. Yeah, no, that's not what we want. No, we want run h3. That's eval. Okay, so let's just try and create a thing with this, because right now we have been struggling with types, but we haven't done anything with it. So and of course we're floating way high here, so So that's not going to help us, except if there were examples, but I believe there aren't, especially not the arrow sorts. And yeah, no, not even edit free for free functor categories arrows. Yeah. So not here. So how are we going to build one of those? To build one of those, we need the type of this somewhere to help us understand what we're doing. And CGFE. There we go. So we need that higher kinded natural transformation, which it feels like a profunctor, but is it the profunctor? Is it the profunctor for P? Maybe not. What's a profunctor? What's the do we have that in our free arrows? Do we have maybe in our design? Can have the co-end way, I think, to describe a profunctor. We don't have it here, no. Profunctor co-end. Polymorphic projection, transformations as ends, ninja lemma. It's for all A PAA. What is for all AB PAB? And this is for AB PAB to QAB. Okay, we need the type of this as well. So if I want to build something of type, if I want to build a thing of type 3A of, let's say, start simple, right? Identity unit. And we need to import what data.functor or something. Maybe. I think import data.identity as well. Functor identity. Then our thing would in fact be a natural transformation that takes any PAB to some well, no, it takes such a function P and it returns, and the function P is like so. We want to construct it, so we need to say HH3. But we could pass its identity or something. What's the problem with that? Oh. Right, F is, now. Okay, so let's just say like for f, and this is ID that I meant, maybe. And what's the problem with this? It's redundant, okay. And then you can't match the type. Right, because in fact, indeed, you need something that takes x, y. Uh-oh, why has this been reactivated? Very strange. I do have a math thing, but I thought it was disabled. Let's just disable it. X, okay, I need to reload. X, Y, to what? 2 units. Is that a thing? Still figuring out where it is with regards to Haskell language server, I believe. Yeah. And what's up? Unexpected language function application. So this. Okay, let's type hold it. What do you want here? Found hole. Ambiguous type variable. Yeah, I think we're in space land here, so need to think about it a bit better. So it takes a natural transformation, and then it would return the GAB. I never really know how these things work. What is an example I could use? Something like well, my type or even new type. My type equals, or let's say, yeah, no, let's say equals my type, and if I say something like run my type is of type int, then what does it mean? Oh boy. Record construction of data types in Haskell. It's so interesting that I can't build up brain memory for this. It just doesn't stick. That's a record. So when I use the record, I actually have something from car to string. I have something from my type to int. So here I have something from HH3 to this. So I need that whole thing in order to build my HH3. Yeah, there's no such thing as run maybe, right? Okay, constructor. Wildcards. Run or make types. New type. Right, run state. Only for one field. Ah, there we go. Right, so state is a constructor that take the S to SA to a state SA. So that's really what I can't remember what I was trying to see here is this correspondence. That's a fairly beginner's thing, but for some reason it just doesn't stick. But okay, so the constructor takes this S to SA and then gives us the state SA. So the constructor takes this for blah 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 and give us the HH3 blah. So it takes a function that goes from this natural transformation to some GAV, to some G blah blah. And then what can we do with natural transformation? We can only apply it, right? So it's really n. We have this f dot g. This n could call f2g. We get that f2g. What do we do with it? We could just ignore it. Could we actually? I mean, with natural transformations, sometimes you can't. Also with the for all G is tricky there. For all G means that I'm able to return any G. Okay, I might be able to figure it out, maybe, but I'm going to see whether the internet says something about using HH3. free C instance for C of kind that constraint. For example, hash free arrow is a free arrow. Maybe we should lock down. Maybe we should lock down F. But we need something of kind star to star to star. Then we're saying we're taking any F2, in our case, an arrow. So we could ignore the F, could we? No, are we being given a natural transformation from F to G, or are we implementing it here? I think it's being given to us. So if we have it, something from F to arrow, this is really F to arrow, then we want to pass it an F, right? But we don't necessarily have an F floating here, because if that's polymorphic here, then we tricked. So we need to find something here, like maybe there's H identity. There might be H identity actually. Okay, that makes sense. Maybe. Oh, I'm getting tired. It's getting 9:39 too. HH free. Haskell higher candid identity functor. Multifunctor. Suppose we could use K. Would that could we define such a thing? Identity, like H identity, AB. What would that be? Would that just be like a singular thing? Or would it, oh no, it would need to be A to B, wouldn't it? And then, what's the dealio there? Should have two arguments. Well, oh. Right. Or hold on. Can I do star here? Is that how it works? Or is that the data thing? I need to do data and then H identity AB blah. Why not new type? Multiple declarations. Okay, I forget how we do this. Data K AB. How Haskell kind declaration. Kind. Come on, I also kind declaration. So you don't have kind. Another kind of declaration. A kind system. Do I have to? Oh, I see. Okay. AB to A to B. Really? Is that a thing? Maybe we do that. Well, A to B. Illegal generalized algebraic declaration about GDTs. Can signatures. Instance type B instead of an instance of its parent type. Oh yeah, right. Ah yes, okay. Yes, H identity AB. Yeah. So now this types checks, and now we have something that goes from H identity to arrow. So if we pass it an H identity like to arrow like ID, except that's the category ID. That's why this is not gonna work. Maybe. Okay, so just x to x. How about that? Right. We want xy to maybe we want H identity xy to X identity ID or x to x. No. H identity is applied to too few arguments. Yeah, so you need an A and a B. Okay, fine, I give you an A and a B. Oh, well, this type checks. Haha. Well, it's a thing. It's a thing, and I'll stop here. Definitely hovering into space a bit, but at least we've got these two type checks, which means next time we go into this graph module, which I think maybe we should call something different, like free arrow, maybe HH free arrow. How about that? And there we go. Then we'll continue with HH free arrow. Why do we want to go there? Because it seems like it's going to give us something that could be faster than our current representation, and something that could give us, okay, I'm going to write this down at least here. Using HH free seems to be able to give us one would be right, no need to create functor and category instances for a base functor or pattern functor. Performance because of CPS, and well, a more general abstraction. Specialized to arrows, which is pretty neat. And it seems like maybe eval and maybe eval for free, or eval as part of runhh free. It has like all the instances, which is cool. So I mean, the educational aspect of it is obvious. I'd love to be able to understand this a little bit better in that language. And so that's fine. So next time where we shall try, we kind of went a little bit sideways here with HH3 arrows. I think I'm missing something about the reasoning behind going there. I was trying to get, effects, and so therefore to be able to maybe interpret into class DIO or something like that. So it seems like that's a cleaner way to get effects than this approach. Then the extensible arrow approach. And it means also like there's something about yeah, I suppose getting extensible effects as well. Nothing prevents us to have MTL style type class for F. So maybe a path towards a deny way to stack effects. And that was the main driver here. It was that I just noticed that I might need time to be put into the arrow. Then I was like, well, with this free arrow approach, this one, we don't have effects at all. I mean, we could put them in the profunctor, but then also this seemed like maybe we've already outgrown it. But we don't really want to go this route because it seemed like a bit ad hoc, like, and so definitely this HH3 arrow seems like it has equivalent power, maybe more performance. Obviously, barrier to entry is higher, but seems worth it. Because yeah, I can't wait to be able to play with this more. So let's write that yeah, we're doing HH3 arrows, and so we want to what? Implement simple implement the, in fact we want to implement the free A examples with HH3 arrows. I think that's the way to go, and then we'll want to still play with interpreters. Cool, excellent. All right, hey, that was it for today. Thank you so much for watching, and yeah, see you on Saturday. Maybe I might skip Saturday. I'm not sure yet. But if I do, then, you know, I'll be back and I'll continue working on this. It's fun, and definitely my brain hurts, which is a good sign. It means I'm learning something. All right. See you later.